be having. To begin, we need to graph our quadratic y equals x squared plus 4x plus 1. So, in the last chapter, we did graphing. Currently, I would stick to making a t-table. So we're going to have x, we're going to have our y's, and we're going to find values in order to make our parabola. First thing we need to find though when graphing a quadratic equation is find the vertex. So our vertex, opposite of b over 2a, our vertex is at -2. So if we pick out some other points, -1, 0, -3, -4, I'm going to start with 0. If we plug 0 into everything, we'll get 1. -1 would give us 1 minus 4 plus 1. 2 minus 4, -2. -2 gives us 4 minus 8 plus 1, which is -3. -3 gives us 9 minus 12 plus 1, which is -2. And -4 will give us 1 again also. So once you find points to graph, go ahead and put them on. So we have -4, 2, 3, 4, 1, -3, -2, -2, -3, -2, 1, -2, and 0, 1. So we can go ahead and graph our parabola. Remember, parabolas have a U shape at the bottom. And so that was previous information. However, if we're then given a system, we have graph our system. Notice we have our quadratic right here, which we just graphed in the blue. But now we're also given a linear equation to graph. And these we can graph using what we know about slope-intercept form. M, or our slope, is 2 over 1. And B, or our y-intercept, is -1. And just by looking at the line, the equation we can graph. So we start at -1, and we go up 2 over 1. We can also go down 2 over 1. And so on and so forth. And we can construct our line. And so here we have our two equations of our system. We have the parabola and we have our line. How many points of intersection do they have? Or how many solutions are there? Notice they do not intersect at all in any point, so no intersection. So there are no solutions. And there we go. Graphing was our first example. Next, we want to solve the system using substitution. So substitution, remember, we replace something with something else. If that's one way to say it. With substitution, the nice thing is that they're both set equal to y, just like our example, then we just set the rest equal to each other. So, they're both equal to y, so we just set them equal to each other. So we're going to take our linear equation, 2x minus 2. We're going to set it equal to the quadratic, which is x squared minus x minus 6. From here, we just need to solve. So, whenever we see an x squared term, we're going to want to get everything to one side because we need it set equal to 0. So I'm going to add 2, and I'm going to subtract 2x from both sides. Add 2 and subtract a 2x. When we do that, the left-hand side becomes 0. And on the right-hand side, we have x squared minus 3x minus 4. From here we have multiple different ways of solving, which we've learned about previously. And so we can choose from graphing. We could do factoring, solving using the quadratic equation, solve by completing the square. And so you can choose any method you'd like. Looking at this one, I can see that factoring is going to be the easiest. So I'm going to factor. 0 equals x. Multiples of -4 that add to -3 are -4 and +1. When we solve for factoring, we then have to set each portion equal to 0 because of the zero product property. So we have x minus 4 equals 0, x plus 1 equals 0. Then we have to solve each of these, so we get x equals 4 and x equals -1. However, when you solve systems, a point is not good enough. For a single x, we need the whole coordinate point. So we have to plug -4 into an equation and -1 in. I'm going to pick this linear equation. It's a little easier. So I'm going to get y equals 2 times 4 minus 2, if that's my x. 8 minus 2, y equals 6. So that gave me the ordered pair, 4, 6. I have to do the same thing with my other x value. I get y equals 2 times -1 minus 2, which is -2 minus 2. So y equals -4. So my other ordered pair is going to be -1, -4. So right here I have two solutions to my system. And last but not least, we want to double check them quickly. So if we plug in 4 and 6 and -1 and -4, do we get true solutions? We know they both work in the bottom one. Let's double check to see if they work in the top. Does 6 equal 4 squared, which is 16, minus 4 minus 6? Yes, it does. And does -4 equal -1 squared, or 1, plus 1 minus 6? Yes, it does. So our solutions check out. And so 4, 6 and -1, 4 are our final solutions. And we have two solutions. Last but not least, we have solve using elimination or combination. Just like when we solve with linear systems, we want to make sure everything lines up nicely first. So right here, I have x squared over 2x. I don't like that, and so I'm going to rewrite this. I'm going to rewrite it so that I have y equals x squared plus 4x plus 3. And then I'm going to have y equals 2x plus 6. Notice how I left a blank here since it had no x squared. So here we do not have opposites yet. And so I'm going to make my y's opposite. And to do so, I'm going to multiply this bottom equation by a -1. So I'm going to have y equals x squared plus 4x plus 3. And my bottom equation is going to become -y equals -2x minus 6. And now I can go ahead and add these equations together. Y minus y will give us 0 equals x squared minus nothing is still x squared. 4x minus 2x is plus 2x. And 3 plus -6 is -3. Notice we have a quadratic because of the x squared, and it's already set equal to 0, so we can go ahead and simply solve for our x. Any method you prefer. I'm going to choose factoring in this case because it will be the easiest. 0 equals factors of -3 that add to 2 are +3 and -1. However, we need to solve for x, so with the zero product property, set both equal to 0, x plus 3 equals 0, and x minus 1 equals 0. And then we get x equals negative 3, and x equals 1. However, this is not our final answer since we need to find our ordered pair solutions. So, let's see what our equations were. I am going to plug my x's back into my linear equation. It's a little easier for the math. So I get y equals 2 times negative 3 plus 6. That's my x, which equals negative 6 plus 6, or 0. So we have potentially the ordered pair negative 3, 0. And we also have y equals 2 times 1 plus 6, 2 plus 6, y equals 8. And we have the ordered pair 1, 8. However, we need to always double check our answers. So, we know they work out in the bottom one since we just solved with the bottom one. So let's check them in the top. Does 0 equal negative 3 squared, or 9, minus 12 plus 3? Yes, it does. And does 8 equal 1 plus 4 plus 3? Yes, it does. So both of these check out, and we're ready to go. You can check the bottom equation also, but seeing as how we just did it here, it's just redoing your work. Both solutions work. Both solutions are answers to our system.